Class 8, already halfway. I just got to say that I'm really enthused with the interactions that I'm having with people in our one-on-ones, that they're really getting what we're talking about. And that is, we're trying to teach everybody to be an AI wrangler, right? Use AI as a force multiplier. And it makes you a data scientist, right? It makes you a developer, and you're able to take your ideas, and instead of getting stuck behind somebody and waiting for somebody else to do it for you, you can just do it yourself, right? And now that you have this knowledge, you can really start cranking on some of this stuff, and hopefully it's going to put you at a competitive advantage and help you deliver a lot more value to your stakeholders. Tonight, we're going to talk about AI for incident response. Going to skip right through housekeeping. Uh, Syllabus class 8, we're halfway, hard to believe. But here we are. Um, Assignment, no assignment tonight. We had one last time, feature engineering and visualization. There was a question. I did not post the original full assignment to Google Classroom. I posted it to the Discord chat, but it's up there now. So if you have any questions about what's in the assignment, please check Classroom again, and there's a PDF up there for it. Okay, so tonight the agenda, we're going to cover 4 main areas, and they're going to build on the previous ones. We'll talk about a quick case study. I apologize, we were supposed to have a guest speaker tonight, but he's at Hacker Summer Camp. He's going to join us next week. One of my former colleagues from Microsoft and Amazon. He's in charge of threat intel for them, so it should be a good discussion. And and again, feel free to ask questions as we're going through this. Um, I always joke and say I'm going to run over, and it's probably true, but I do want to make sure that we answer questions, and I can kind of skip over stuff as it makes sense. So let's begin with the foundations, right? What's AI for incident response? Um, well, this is kind of where the rubber meets the road, right? Is that we want to detect anomalies in our cybersecurity environment, and we want to take action. And by taking action, we either remediate an issue or we address a possible infiltration. So this is the shift is, though, that we're going to try and accelerate security ops with intelligent automation driven by artificial intelligence. So let's talk about what we're going to cover today. Um, we're going to talk about how AI automates incident response, the what and the how. We're going to analyze some AI-driven threat intelligence, a little bit of critical thinking about data correlation, evaluate AI's role in SOC operation, what's the strategic understanding, and what do we want to convey to leadership, because really this is what this is all about. If you show up with data and you show up with visualizations and you can explain what your thought process is and why it's important, you're more likely to get sponsorship and action to achieve some of your objectives. So these are the kinds of skills that you'll need as a SOC analyst, an IR specialist, or a security architect. And the automation piece is crucial, right? Because nobody wants to sit in a swivel chair and go back and forth between two different screens, right? Looking at, Splunk, and then opening tickets, right? That is a waste of our time. We want to be focused on more value providing activities. And that's what these tools will help us do. We can automate the work, and we can focus on higher objectives. Um, I've been a SOC analyst before. It can be drudgery, especially back in the old days. And with the advent of some of the technology that we have at our disposal today, we can really help start moving things forward. And these are all tools, again, that are available to you as a security professional. We don't need developers anymore because we have LLMs. We don't need data scientists anymore because we have LLMs, and we use our domain knowledge to look at the results we get from our prompts and make sure that they make sense. So before we dive in, let's make sure we understand the challenges of traditional incident response, right? This is we talk about the good, the bad, and the ugly. This is somewhere between bad and ugly, right? So, incident response is an organized approach to handling security breaches and security incidents, right? Um, and it's not just about fixing the problem. You have to do recovery and you also have to learn, right? So I don't keep doing the same thing over and over again. So there's four goals. You got to contain the damage. This is, stopping the flood, and you got to prevent the issue from spreading. You need to eradicate the threat. So what's the root cause? Uh, Make sure that you got that, not just the symptoms. I was involved in a compromise, I guess it's been about 10 years ago now, where once the adversary realized that we had detected them, they disappeared from our environment and we didn't know where they went. And it was kind of disconcerting, right? So, um, you have to make sure you have assurance that there's not a command and control link or persistence and they can come back. Uh, you need to recover affected systems, get things back to normal operations safely. Uh, Back in the old days, this meant burning down servers and rebooting them. Today, hopefully, it's just Terraform and I'm going to regenerate my Kubernetes cluster. Uh, Sometimes it's not quite that simple. And then what do we learn? We need to improve our defenses for the next time. So it's a continuum. It's a flywheel. We do these things over and over and over again, and it should be an automated, known process. So we're not making stuff up as we go along. Why is it challenging? It's time sensitive. Every minute counts, right? Our adversaries do not wait. If they get in and get a toehold, they're going to try and expand as much as it's possible, right? If you've ever worked a breach and you've tried to track pivoting behavior inside of an environment, it is pretty amazing what adversaries can do. Um, Complexity, right? Modern attacks involve multiple vectors and systems. Adversaries often have ways it's like once they breach the castle walls, they have free reign. They can run wherever they want within certain constraints. Um, it's high pressure. Um, I've been on really bad incident bridges where there's 100 people and all of a sudden some corporate vice president says, I'm in charge and I want you to do this and that. And it doesn't make any sense what they're asking, right? Your business operations and your reputation is at stake. A long time ago, I worked an issue where a customer of mine was getting DDoSed on their most important day, which was Christmas, and we had to figure that out. Try getting someone at a carrier to provision circuitry for you on Christmas. It's not fun. And uh, you need to have diverse expertise because you require all different sorts of assistance. There's legal implications, there's technical implications, there's business, there's all sorts of issues, and you need to have a full team at you. We're not going to dig into this, but look at FEMA ICS framework, the Incident Command System, and that's what we used at Amazon, Google, and at Microsoft. So that framework is super important. So, real world, Target, they detect the breach. It takes a year to clean up. Same thing, Home Depot, they have a bunch of issues. Equifax, incident response is almost as damaging as the original breach. So you have to do this right. So the biggest challenge, right, is it response time? Is it complexity? Is it something else? It can be a combination of all three, right? They all kind of work in concert with each other, and it's a big swirling fur ball, and you have to be able to navigate your way through it. And this is why AI is becoming valuable. Let's talk about how automation is going to transform the process. So again, I talked about this flywheel, right? Um, it's a continuous cycle. It's not a linear process. You're never done with the incident, right? It's a continuum. Each phase is going to feed information back to each other. The first thing is identifying an incident, right? You need to identify it, you need to report it. Um, it used to be back in the beginning, we had atomic detections that says if something exceeds a certain value, we're going to fire an alert. That caused a lot of false positives. The fidelity was not that great. And in the context of what we're doing now, AI can help because it can help us prioritize incidents. We're going to look at some other ways we can do that. And it lets us focus on what's important. Not everything is important. Um, when I was leading the blue team at Microsoft for Bing, we had 500,000 incidents a month. And we had to distill that down to maybe 100 things that we could actually act on. So we had to use techniques to distill that down, improve the fidelity. And a lot of times it's triage, right? What do I have time for and what don't I have time for? Make sure you're spending time on the most important stuff. And you know, with respect to coordination, right? Triage and team engagement, AI can help you prioritize. Resolution, right? How good would things be if we started a post-mortem as part of the incident? We started collecting all the artifacts, right? There are some frameworks that do that. If you look at DF Time Wolf and Turbinia, which are open source things from Google, they help do some of that stuff. You need to put things on a timeline, tell what happened when, and that helps you with the postmortem. Um, you know, Resolution, right? What did the investigation say? How do we know that the situation has been resolved? How do we keep it from happening again? It doesn't do any good if you resolve an issue and put a vulnerable service back into play and it gets compromised almost immediately. You're just making yourself more work. And then with respect to postmortem lessons learned, this is super important. I don't think it gets done enough. If you go back, uh, true story, when I was working at Google, we had two different approaches to a cause of an incident. One of the conclusions was a qualitative solution, which said, oh, we have this issue, so we need to do more training. Well, that doesn't stop the issue from happening. But if you look at a quantitative solution, I can tell you what the issue is, why it exists, and what control do I need to put in place to prevent it from happening, right? Um, Training is not a control, right? Having a system in place that prevents a user from making a mistake or something bad happening, that's a control, right? A control is something technical. So a lot of times security is, we talk about it just being good, right? What does good mean? Can you quantify that? Is that what's our inventory coverage? What do we have as far as installed XDR on hosts, that kind of stuff? So always be thinking quantitative. Everything is knowable, everything is quantitative. If you look at any system, there's metadata available to you that you can pull and you have at your disposal to help you make informed decisions. So always look for a quantitative way. Don't just say, yeah, it's pretty good. And then continuous improvement, right? We're going to learn from each lesson. And instead of us humans doing it, let's figure out how to make AI do it for us. So if you kind of look at this, it says incident response process in the center. AI doesn't replace it. It just accelerates and improves it. So think about each step of the way. How could you use AI and automation to help improve it using some of the skills that you're learning here? So let's dive a little bit deeper into how AI automates these workflows. Okay, so this is an example that I did. And basically what I did is I asked my LLM to create me a demonstration of an AI-assisted incident response. And it created some synthetic data. I've got triage prioritization, response workflows, which are playbooks, right? Uh, Threat intelligence correlation using, of course, fake threat intelligence, but you could probably patch something in here pretty easily. Just ask your LLM to do it for you. Anomaly detection for SOC operators, dashboard simulation. I've got something really cool I'm going to show you towards the end, but this is all generated by LLM. I had to futz around with it, as you all know, because you've been doing this, right? Sometimes you have to ask a couple of qualifying questions and pull some hair out. But I got to this, right? And here, let me, before somebody says that, I'm going to zoom this. Okay, so I generated the synthetic data. It tells me a little bit about it, right? And then it does triage and prioritization, right? And it divides my incidents up that I just created and gives me this nice visualization. And it feeds it right into the incident response workflow. So this is cool because the AI categorizes the incidents into 4 priority levels, which I'm sure y'all are familiar with. Um, what does it tell me? What percentage of the incidents make up the largest portion? P2. Okay, P1 critical incidents are properly identified as the most severe, requiring immediate attention. And then the prioritization prevents analysts from being overwhelmed, right? So instead of it just being a queue full of random incidents, I have to go through and triage and figure out what I want to do. This tells me, right, these are the incidents that I want to dig into. And I'll show you in a later example how we can make this information come to life and make it useful to an analyst or to a leader, right? So now I know where my instances are. I know what the priority is, and I know which ones from a confidence perspective I should be working on, right? So I bet you if I just chunk these off anything over 80% confidence, that's probably 20% of all the incidents. And that's more doable than this whole body of incidents that we have here. So this shows you how machine learning can process multiple factors and make intelligent decisions. And you can see the patterns, right? The priority and confidence is pretty good for a lot of the criticals, and it becomes less and less with the lower scored incidents. And what does this tell me, right? Is if I was going to treat all these equally, I would spend most of my time chasing things that probably don't make that much of a difference, right? If I just look at the critical incidents and focus on those and maybe some of the P2s, right? That's doable work. I can make a difference. But if I have an entire sea of incidents that I have to troll through, right, I'm never going to get anything done. So this shows you how it works in practice. Let's talk about the mechanisms behind the automation. So, the traditional problem with IR is manual processes mean inconsistent responses, right? Everybody does it different. Am I tired? Do I have a headache? This sucks. I've been going through 500 of these today. I'm just going to click the button and move on, right? There's a human in the loop, right? There's somebody sitting in a swivel chair trying to figure this out, and they probably don't want to be there. Repetitive tasks. I know there's some of you that probably have roles like this where it's like I am might as well be stamping numbers on a box or something like that because it's a repetitive task and you get tired of doing it and there's going to be errors. Early in my career, I was a network engineer. We had a client that hired us to go and figure out a wiring mess that they had in their closet. And I spent weeks working all night toning out cables, trying to figure out where all the terminal servers were plugged into their terminals in a hospital. And it sucked big time, right? Nobody wants to do that kind of stuff. So we need to figure out a way to automate ourselves out of that. And then the other reality is scale, right? The attackers can move faster than us because they're using automation and there's multiple vectors that they can employ. So if you spend a lot of time doing triage and analysis and stuff like that, it's, what about the stuff you're not getting to, right? So this is super helpful here. So with respect to triage and prioritization, AI can analyze thousands of alerts and rank them by an actual threat level, right? Because it's looking at the entire estate instead of you trying to figure out, is this real or isn't this real? AI can correlate a login anomaly with malware detection to elevate priority. I was having a discussion with somebody earlier about this, right? What is how do you know if your algorithm is working? right? How do you know if it's drifting? You train it and then you implement it, but how do you know you're catching all the malware? You have to look at the secondary indicators to see, am I getting malware detections? If they are, do I need to retrain my algorithm, right? So this is super useful. And this can be helpful because it can reduce your false positive fatigue. And a lot of times people see 80 or 90% reduction by implementing some AI techniques. Automated playbooks. This is super critical, right? Is you uh you know, you ever open up a document that says this is a playbook for an incident and you got a Word doc or a PDF or something like that? That doesn't do you much good, right? But what if you had a Jupyter notebook that automated this stuff? And if you clicked into it and it went out and it got you information, it got you context, it got you logs, it created some charts for you, it helped you identify systems and did that kind of stuff. So think about the work that you do to prosecute an incident and how you might automate that using some of the technology you have at hand. I can tell you this from working at Amazon, we put a satellite constellation in orbit and all the operations are run with Jupyter notebooks, right? Our mission automation engine for Project Kuiper is Jupyter notebooks. So it's no joke. They're quite capable. Um, and your AI can trigger the appropriate playbook based on the type and severity, and it can take action, detect malware, isolate host, block IP, notify team, and all that can be automated. This is super important contextual enrichment, right? How do I gather background information about a potential incident, right? If I have anomaly, I can start collecting information if I have the ability to run that through a notebook, right? If anomaly occurs, start collecting more information. You can pull in threat intelligence, user history, asset information. This person logged in from a weird location and they're suddenly uploading files. Oh, that's not normal. That's not their normal pattern. Maybe we should force a password reset, right? Do something like that. So these are all things that you can automate away using some of the tools and techniques that we're learning about. Um, so we talked about alert fatigue. AI can filter out noise. Analysts can focus on real threats. And machine learning is going to improve over time to understand what's actually important. Um, I've noticed this. I don't know if the rest of you have as well. The more that I interact with an LLM, the better results I get, and it gives me what I'm looking for. So unfortunately now, when I ask questions, I get a lot of code when I'm talking to Claude.ai. So I have to ask it for documents or a summary or something like that. But it does learn context and that can help you build the tools you need to solve problems, right? Um, the impact of it is faster response time. I think Microsoft went from days to hours. Uh, Increased efficiency, right? You can handle more incidents with the same staff. We're not talking about replacing people. We're talking about doing more. If you look at how much stuff actual SOC gets to historically, it's a smaller percentage. And if you automate a lot of the drudgery away, they can get through a larger percentage of potential incidents, right? And improve your security posture. And then you have consistency, right? Quality is the same every time. If you use automation and runbooks, you don't get variable result. Everybody doesn't investigate the same way. And if you automate it away, you're going to get a better result. And then that's going to help you out in the postmortem process. So, you have to think about what of these capabilities might have the biggest impact on a SOC. And then also you have to consider what are the concerns that leadership and security teams might have, and also operational teams, right? I don't want some automated playbook to isolate a host and potentially take our email service offline. So those are the kinds of questions when we talk about explainability that you need to be ready to answer. So automation is powerful, but it needs intelligence to work effectively. So let's talk about AI-driven threat intelligence. So it's again as another flywheel, and it flows in a continuous circle, right? Um, what we are looking at is AI is going to help us accelerate this. So um, I have interviewed people before for threat intel jobs, and their explanation of what they do with threat intelligence is, oh, I make a newsletter and I send it out to leadership. How do you gauge the impact of that, right? Um, Unless it is contextualized and associated with actual operational issues or incidents, I don't think threat intel does you a whole lot of good. It's like the newspaper. It doesn't, I mean, it's information, but it's not making any impact. How do you measure the impact of threat intelligence?
Steve.
So, yes.
Okay, so you said that you interviewed some of these positions as a threat intelligence guessing engineer. Can you explain what good like roles and responsibilities that they have on their resume that you would see as a strong threat intelligence engineer?
Well, what I would say a strength would be that you take threat intelligence and you use it to proactively enrich um, your detections and also your workflows so that if I'm looking at a potential issue, I know that it could be an APT, it could be associated with a certain kind of malware. There's an attack that's going on. This IP block looks like it is in uh, an area where we see activity from you know uh, you know Russian hackers or something like that. But it's really it's about so what you really want to see is you know threat intelligence is correlated with the TTP, and then the TTP matches to some degree with activity that you have going on, right? So you could think of it this way is if I was going to train a model to look for specific TTP activity, right? How do I find what is potentially TTP activity and what I don't? I mean, think about some of the mechanisms or methods that we've explored in this class. Um, you could flip the script with what we've been doing, and you could say that these are the things that compose TTP activity, and anything that's not this isn't TTP activity, right? So you could use like one class SVM or something like that to figure it out. And what you and what I've seen in the past is this is let's say I get a connection from a region and I'm having a traffic issue. Where is the that origination from? Is it from uh, a cable modem IP block in the Netherlands, or is it coming from Estonia, right? Which it is associated with potential criminal activity. So I want to know, right? What's the context of the alert, and what is the potential associated with it, right? So, what does this mean? And then also, what are other things in my environment that I can correlate with this, right? So, I'm trying to bring a picture together, and I have different pieces of intelligence that may fit one or the other um, kinds of threat intel. And is this a campaign? Is it an information stealers? Is it malware? Is it command and control kind of activity? And that's what I want to see in context with my alert. I just don't want to see, oh, you have a connection that came in from Estonia. Does that make sense? Okay.
Sorry, I was on mute. So it seems like you just would look for someone that does, I guess, a lot of data analytics to analyze the data and make it kind of.
It's It's art and science, right? So you need to understand what the sources are, right? And then you need to correlate your data sources with activity, right? So, let's say a certain APT has a pattern that they use for attack or certain tools. And if you see evidence of those tools running, you could say, oh, this is possibly activity from this particular APT. And then you try and get more information. What's the origin of this attack? Oh, it looks like it's a IP address block in Estonia. Does my threat intel say about this IP address block? Oh, it's a known command and control block, for a particular malware, right? And those kinds of things, putting it together is is what we're talking about, right? So we'll get into this a little bit more, but what you want to do is you want to personalize the threat intel for the organization and by the type of detection, right? So if I detect an anomaly, it could be a bunch of different things. And I need to provide that context, but I also need to try and gather more information to try and pin it down. So if I think it's potentially 5 different types of APT activity, what other pieces of information do I need to get to try and nail that down? So I have a connection from an IP address block and it's to a particular kind of host. And then that host is, there's certain activity on it that's associated with it. So what I'm able to do is I'm able to triangulate on the specifics, using something like MITRE ATT&CK and use those elements to try and enrich that detection to the point that makes it more actionable, so I know what's going on, right? So what we're doing is this a campaign against us? Is this a singular compromise? And try and analyze those kinds of things, because there's a big difference between something like um, password spraying and a directed attack, right? There's a difference between low and slow communication to a known command and control uh, IP or location and other types of activities, right? So you want to try and separate that needle through the haystack and correlate all those different things and try and figure out exactly what's going on.
Got you. Thank
All
you.
right. Sorry, long-winded explanation, but good question. Um, All right. So what does the cycle do, right? We collect data, right? So AI is going to gather threat data from multiple sources, right? We have all our threat feeds. Um, and this is going to feed into AI ML model training. And we're no longer limited by human capacity to monitor sources, right? You don't have to say it's like, oh, I'm going to go look at my threat platform and I'm going to see if this IP address is associated with any known campaigns or if it's a bad IP block, right? You don't have to do a dig or something like that, like we had to do back in the old days, right? So that is super helpful because it's able to gather context automatically and correlate it to the event that you are working on, right? Structure and enrichment, right, which is the next block, right? So AI is going to parse and enrich the raw data using AI ML based information extraction. It's going to normalize different data formats into consistent structures, right? This is kind of like what we did with pre-processing data, where we scale it, right? We're looking for deviation from the mean. We're comparing it to the rest of the population, and it's going to add context and metadata automatically. So when I look at it, I know what the potential is, and I can also see maybe I don't have a clear picture right now, but I can see, oh, maybe this might be APT activity, so I want to take it seriously. Um, then we talk about analysis, right? AI is going to process the amounts of data for insights. It's going to help analysts prioritize, right? We still need analysts, we still need people, but they aren't doing all the grunt work. They're going to help prioritize and process this and help with scoring and summarization, right? And this also feeds back into training our models, right? Because we have examples that we can use to train our supervised learning part of maybe an ensemble model. And then it also this is the big thing, is it does pattern recognition at a scale that's impossible for humans, right? Because when we look at data, we've done this a couple of times. If you look at a spreadsheet that has a bunch of data in it, how much can you take in, right? That's where we start doing pivot tables and a bunch of this other stuff to try and summarize the data, but it's slow and it doesn't scale. So that's why that's the value of AI, is it can help um, automate some of that for us. I was talking with somebody, and there is a term, they call it a mechanical Turk, right? Where essentially you have a mechanism that does something simple for you and it does it over and over again. We make AI our mechanical Turk for a lot of this stuff. Um, Analysis, right? Uh, we talk about the amount of data that we process, and then we talk about the disseminate and deploy, where we personalize the threat intel for each organization, and we enrich the detections and reduce the times that it takes analysts to respond. And we can automate the distribution of this information to the relevant tools. Planning and feedback, we can refine future collection efforts, use the detections and feedback to tailor future efforts, right? This is what I was talking about when I talked about, you can use this as an input for supervised learning. And this continually helps us improve as we execute this cycle. So, real world traditional threat intel used to be, like I said, like getting a newspaper. And AI makes it like having a live news feed. I guess it's the difference between, do you get a newspaper? It shows up. It's yesterday's news. It's it's on your driveway, and your dog goes out and gets it, which is kind of cool. Or do you just open your phone and watch what's going on one of the news networks or a live feed? Right? It's a big difference. And the challenge isn't getting the intelligence, it's processing and correlating it and using it, right? Because we aren't building newsletters here. We need to connect threat intel with actual events, and it helps us provide context so we can prioritize and get a picture of what's really going on. So let's see what this looks like when AI processes threat intel data with numbers and patterns. Okay, so again, this is from my lesson here, right? And what my demo does is it has automated response playbooks for different incidents, right? And based on the type of incident, it executes certain tasks, right? So let's say for privilege escalation, I want an analyst to look at that, right? DDoS, I can automate that, right? That's not even a security incident in most places anymore. It's an operational event, and it gets handed automatically by the DevOps infrastructure, right? Phishing email, we can take some automated actions there. So these are all the things that that in this particular demo, I have an AI automating for me, right? So these are synthetic events, but it is real algorithms that are taking this action and are executing these automated events, right? And this is kind of what it looks like. So you can see that you have the different sources. It gives me the correlation score. This is it only has one hit, so this is not that exciting, but it basically says this one particular event happened, and I have an 80% confidence that, based on the multiple sources of threat intel, that this is an actual event, right? So this is something that based on the severity, I might want to jump on, but this just shows you in a very simplistic way kind of what that looks like. And then it also shows you the different threat intel sources, right? So again, simple demo. We'll look at a different way to look at this in a little bit. And the first graph is intel by intelligence type. So IP is the largest category. That's often a big source of it. We see these often as the first indicator in attacks. Hash values, that's What do my files look like? Am I seeing strange files? Why is that? Why am I seeing a strange file? Maybe something updated or we push some new code, uh, but I need to go look at that. Different indicators require different approaches. And the benefit of doing this with AI is it can handle it automatically. So, the upper right is the threat type distribution. It shows the threat landscape breakdown, right? And it basically gives you the percentages of the types of attacks that are being seen out there with respect to threat intel. And you can see this is a balanced distribution, so there's not one thing that really dominates. And that's probably more real world, depending on if there's a campaign or not. A lot of times you'll see a threat types jump if there's a particular kind of campaign going on. We talked a little about the correlation score distribution, right? That's how confident our AI is in the correlation. And then the lower right is the threat intel sources. This tells you how many sources there are per feed. And this is, again, a demo. You would have numbers that are a lot larger than this. There's thousands, sometimes hundreds of thousands, millions of threat intel sources, which is more impetus to the fact that we need a different way to address these than just an analyst trying to go through and fill out a newsletter, right? So this represents, right, in our fantasy world, like one day's worth of processing. And if you multiplied it by, even with this example, by 365 days, that's a lot of stuff, right? Uh, how many indicators can you process a day manually? If you're good, 50 to 100, maybe, depending on what depth you need to go to. But this simulation process is data in seconds, right? And it would take you a lot longer to go through the data and try and pick it out. So, you know, companies can process, again, millions of applicant threat indicators a day. So we need to find a different way to do this. Um, so, the volume can overwhelm human. You need automation for prioritization and importance, and you have the challenge of maintaining data quality. So when we talk about incident triage, right, the threat intel directly feeds into that AI triage system, and that gives you the context you need for accurate prioritization, right? That context tells you which things you should be working on. So this is what makes AI-driven threat intel so powerful. And let's talk about some of the specific mechanisms. Okay, so the challenge is that you receive threat intel from tens, dozens, hundreds, maybe sources. Lots of indicators, maybe millions, IPs, domains, file hashes, attack patterns, and you can't manually correlate it at scale. You need to have the ability to automate ingestion and analysis. So AI continually monitors your OSINT, your open source intelligence, or your intelligence feed doesn't have to be open source. It can also process your feeds in real time. And it's more capable of monitoring multiple threat sources and doing correlation than you as a human can. Because as far as pattern recognition, right, the AI is going to identify relationships that humans would miss, right? We talk about analyst fatigue, and you're just not going to be able to humanly do it. Yeah, David, your question?
I'm curious, Steve, with threat intelligence, uh, adjusting that into your, normal patterns. Kind of a broad question, but what's the best way to do that? If you're using Burp Suite, if you're using Microsoft tools, I've struggled with that. So I'm curious if you have any comment on that.
Well, I think you need to figure out what are you going to correlate on, because threat intel has elements of the data that you can try and associate with different events, and you need to figure out what is that correlation, right? Is it if you're looking at network traffic data, is it source and destination addresses, those kinds of things, types of traffic? um there's certain activities, right? Is it a campaign? Are Are people scanning? Do we see command and control activity? So what you try, it's like when you're doing SQL and you're trying to figure out what the join is, right? So how do you join your telemetry to threat intel? And that is the trick. There's a number of different strategies, right? But usually it's, on something immutable. I mean, it's, back in the old days, you could just search through logs and look for Mimikatz executing. But maybe you're looking for a combination of things. If you look at MITRE ATT&CK, if you're familiar with it, what it does is it has the TTPs, and you're able to develop a picture of who the adversary is based on the tactics, techniques, and procedures. So if you see credential dumping and access from another specific IP address block, it might be associated with an APT or some kind of campaign. So I think that's part of it is, um, what does the threat intel tell you? What are the indicators that are associated with it? And then how do you join those back to your actual data, right? So, you probably wouldn't normally expect to see communication to a potential C2 block. So if you see that kind of communication, you can associate it with a particular attack, and then maybe you go look for some other type of behavior, right? Maybe we have anomalous processes running. Maybe we have some other kind of potential pivoting activity and stuff like that. But it helps you draw that picture, right? But that first association, that join, is really the key piece, right? What is the indicator that you're looking for that you can associate with a particular piece of threat intel? And it might associate with multiple pieces, but then you got to try and narrow it down based on the technical indicators in the particular threat intelligence. Does that make sense?
Yeah, thank you. I appreciate that. I know that some of the tools I've used often map right to MITRE. You can see like, oh, this is the activity, and here's the MITRE, TTP that it correlates to. So yeah, thank you.
Yeah, you're welcome. Okay. So I think we talked about pattern recognition. I think that, and then contextualization is just what we were talking about, right? AI is going to correlate internal logs with the threat intel. It can do it a lot faster than you can. You could say, hey, we have indication of a campaign from our threat intel coming from this particular IP address block. I want you to go and look at all my NetFlow data and see if I have any communications with these blocks. And if they do, I want you to highlight that, right? So that's the kind of contextualization I think that's super important, right? Your firewall logs and global botnet indicators. I mean, that's money, right? Who am I talking to? Am I talking to anybody bad? And this can provide relevant and actionable insights that are specific to your environment, but it's always, identity. Nothing ever happens unless somebody has an identity, right? You got to look at identity abuse, and there's always communication, right? Communication. This is where we've always catch the bad guys, is by looking at NetFlow, looking at communications. You can look at processes that tip over. You can look at changes to hosts and those types of things. There's a bunch of different ways, but AI helps you out because it helps you scale, right? You can go search through an entire database of NetFlow data looking for a specific TTP in a heartbeat using something like AI, and then you can automate it so it does it over and over again. Whereas it's a one-time deal if you're hunting. Predictive intelligence, right? AI can forecast future attack trends based on patterns, right? Oh, I see these things happen, and a picture looks like it could be something else going on. You can predict adversary TTPs, right? So if I think there's a campaign going on and it could be a potential of 3 different APTs, they all have different TTPs. I can look for all those different things and see where the pattern falls and provide you with more guidance using an AI-driven system than I could with an analyst trying to figure that out, right? And, so an example is, based on recent campaigns, expect credential stuffing attacks in the financial sector. I mean, that's something you could automate and look for, right? What are the indicators of credential stuffing? Am I in the financial sector, right? So that kind of stuff is super useful. Real world is you get real-time actionable insights, right? Instead of overwhelming data dumps, right? How do you correlate? It's like you know, I look at financial data in the newspaper and then I go and try and look at my online accounts on a piece of paper and figure out what's going on between the two. You can't do that, right? So, but if you correlate real-time data with your financial information, you can manage your portfolio autonomously, right? There's firms that do that today. Um, and proactive defense instead of reactive response. We see things happening, we see anomalies, we try and associate it with a potential campaign, and we provide that enrichment to analysts. And if it is something that's going on, we are able to highlight that and take action. And so that's like context aware security that understands your specific environment. Like CrowdStrike processes 1 trillion events daily using AI correlation engines. It's pretty substantial what you can do. So now that we understand a little bit about how AI provides intelligence, let's see how it takes action to contain and remediate attacks, right? So AI is kind of at the center of this. And we're getting to AI versus AI in cybersecurity, where we have adversarial AI that is probing our defenses, and it's doing it so fast that we need AI to keep up with it. There's various attack vectors AI is going to have to help counter. Diraj, what's your question?
Um, Professor, I had a question about the productivity threat intel. Um, so the AI is looking at the data in our ecosystem, and
Yes.
based on the mapping that is coming from the threat intel, that's how the AI is able to detect the MO
Yeah.
or TTP. So
Yeah.
how can we say that AI will be able to predict what next attack would look like?
It looks at patterns in the incoming telemetry, and some of the specific IOCs might change, but it looks at the overall pattern of the tactics, techniques, and processes, and makes a prediction based on that, right? So it looks at the overall patterns and tries to relate those back with TTPs, and it can predict based on that, or at least give you insight.
Okay, so basically, like if there is a nation state group and if one of the attack vector was discovered from the AI, so AI will tell you that the other attacks coming from this nation state is possible in your environment and look for those detection techniques or set up those detection techniques.
Well, yeah, because there's two parts to it. There is the attack, and then there's success, right? What happens afterwards? So let's take a simple example. Let's talk about password spray. Is if I have open ports, let's say I have a SSH port open and I'm password spraying against it. I maybe I don't care so much about the password spraying because they're not able to compromise it, but there might be something else associated with it, right? What's the impact? Is it maybe I'm password spraying and it's actually a DDoS instead of I'm trying to gain access to your system? And I think what it builds on it stepwise, right? So it looks at a particular element of it, and there might be elements that are shared among a bunch of different potential attacks and TTPs, and it tries to narrow it down, right? So it says if I have an inbound connection from a particular IP address range, what are the other elements that would associate this with it actually being an attack? So it goes out and it looks across your environment and it tries to piece that information together. So instead of just looking at auth logs or NetFlow. It looks at the combination of what's going on in my authentication logs, what's going on in my NetFlow, what's going on in my application logs, because I have all these different pieces of the puzzle, and it tries to correlate those together, and it provides you with some percentage of accuracy as to whether it is an attack or not, based on the elements that it's able to discover by going out and looking. So it's able to take, AI can take all of the IOCs associated with all the TTPs and MITRE ATT&CK, and it can go through and burn through all of those and nothing flat. Whereas you might say is like, oh, I got a connection, and then do I see credential dumping, or do I see pivoting, or are they potentially, we fingerprint that they're using a certain kind of tool? As an analyst, you're doing that serially, and you're doing it like TTP at a time, whereas AI is able to look at it all kind of simultaneously. So it gets through it a lot quicker. Does that make sense?
Yes, yes. Like
So
I'm trying
it's
to understand that, like, if one APT is doing an attack, and if the other APT also somewhat employs the same technique and tactics, is there a possibility that AI will try to go and try to see that, like, okay, so this kind of correlates with this APT 13 or something, and
Yeah.
APT 13 will do this. So probably you have to put response strategies or detection strategies around that. Is it like that?
Well,
Or is it will
I'm
it
trying
will
to
be
think
just
of a
with
good
respect to
example.
one?
Okay, so in past life, I was involved in an incident, and we were trying to do attribution, because it mattered which adversary we were up against, and they were both Russian actors, and one of them was focused on scale. They weren't trying to I can't really say. Anyways, so what the deal was is they both had different objectives, and the tactics varied, and you the intent was different, because one of them would use common tools and techniques, and they were more about scale. It's, we're going to cover a bunch of ground. And the other adversary was very focused, and they used specific tools and processes that were novel, but the intent was greater and the payoff was higher, right? So it was. I have a case study that I'll share. I don't have it prepared now, but it's basically this: is it was the difference between, we're looking for a misconfiguration, and we found an unlocked door, and we're going to go in and we're going to clean out your house, kind of thing, right? The intent matters, and the tools matter. Some adversaries only use specific tools because the payoff is high, so they might use a 0-day or other kind of tactics, and that often is what you'll be able to infer from this. Does that make sense?
Yep, now it makes sense.
Yeah,
Now.
it's like am I I guess a military example is, right, am I sending the entire am I sending an invasion force, or am I sending the Navy SEALs, right? Right, you have a specialized team that is very competent at doing some very surgical specific stuff, and they go in and do the job one way, and the other way is, the Marines are going to show up on troop carriers, and there's going to be an invasion and bombing and that kind of stuff. So the objective is different, if that makes sense.
Yep.
Okay.
Like that analogy.
Right. Yeah. So and today attackers are using AI to create polymorphic malware and 0 days. So how can AI help us contain or remediate these kind of advanced attacks? So, we can talk about containment, which is limiting the spread. Remediation is removing the threat and restoring normal operations. We talked a little bit about automated containment, right? Endpoint isolation, that's a common one. Happens almost in every network. Network segmentation, this is becoming, you get put in network jail if you're identified as potentially being compromised, right? This is something you could automate, create a firewall rule to block lateral movement or the ability to access the internet. IP domain blocking, right? We can cut off malicious communications. Credential revocation, we can cause a password reset or disable an account in nothing flat, right? Because we have the criticality and priority assigned to our assets, AI can consider the business impact, right? I don't want to isolate a tier 1 server from the network, but I certainly want somebody to go look at it. Whereas if somebody's Azure subscription has an open port to the internet and unpassword protected SSH, I'm just going to put them in timeout. So this can escalate the decisions based on damage versus business disruption. So it can bring it to an analyst's attention so it doesn't end up in a triage queue, right? You get somebody's eyes on it immediately. So how could AI help with remediation, right? Something simple, right? Quarantine a file, right? I'm going to move a malicious file to a secure sandbox. A lot of email systems do this now, where you get a link to the file instead of getting the file directly. That's a form of this, right? So we sandbox it, and if it's malicious, it's not going to let us open it. I talked about this earlier, like Terraform, right? We're going to restore a system to last known good state if there's a change. Patch management, that's the old tried and true, right? I want to apply security patches to vulnerable systems. A lot of times now, deployment pipelines won't let you deploy unless you have a system that meets all the requirements, right? Pre-submit checks. And restoring proper configurations if they change. Again, this is something that a lot of things like Terraform will do, is if you make any changes, it sets it back after a certain amount of time. AI can adjust strategies based on the attack evolution, right? It can think faster than us. It has a bunch more tools at its disposal. Not that we don't have them, it just takes us longer to deploy them. And it can apply those as the attack evolves. So if initial containment failed, AIs could escalate to more aggressive measures, right? Maybe taking a service offline or shutting it down. And hopefully we're learning from each incident to improve future response. So AI response time is seconds to minutes, humans minutes to hours, and attacks progress on the second to minute timeline. Like CrowdStrike Falcon, 20 seconds, they say, for threat detection. Could take 3 or 4 hours for a manual response to get around to somebody somewhere in the queue, and I have to isolate it because I see some bad action. So, but the important thing is AI still needs a human to help employ judgment for critical decisions, right? There needs to be the HITL, human in the loop. And the complex scenarios, is you probably experienced trying to get your LLM to code, right? There's a lot of back and forth. We don't want that to happen. We need to get a human involved. And what we're trying to do is get AI to handle the routine things, and humans handle the edge cases, right? So the normal bad stuff we want to automate, but the stuff that requires more attention and domain expertise, that's where the human analysts come in. So the role is changing. We don't want people filling out reports, right, saying, oh, this is a false positive. Okay, so fully automated remediation is potentially dangerous, right? because you don't want to be taking critical assets offline or taking systems down unnecessarily. The flip side of that is, right, if I'm an adversary and I know you have that kind of capability, maybe I can cause a outage just by staging an attack that's going to take a bunch of systems offline. So you got to think about that. Um, these capabilities really transform how security ops centers function. So let's talk a little bit maybe about a case study, right? Um, so, a lot of times SOCs are overwhelmed by alerts. Analysts spend a lot of time on false positives. We talked about this. Manual processes create inconsistent responses. Everybody does a little bit different. Have I had enough coffee? Am I feeling sick? Is it close to quitting time? I'm out of the office. Traffic's terrible, that kind of stuff. Analysts get burned out from repetitive tasks. I've been here before, right? You just get totally fried because you're dealing with stuff day in, day out. It's hard, right? And it's if you're on the hamster wheel, getting burned out doing repetitive tasks, right? It's hard to keep up with evolving threats, right? That deep thinking that you need to do. How do I know if I'm going to train another AI model, right? I need to have some of that time, and I need to get off that hamster wheel so I can do that. So if you look at, like we're talking about transforming a SOC, right? How do you do that, right? We can talk about security orchestration, automation, and response. A lot of times this is AI driven, right? It orchestrates responses across multiple tools. So I have a bunch of different tools, and it helps me take action, so I don't have to go to each individual tool and do a thing. Last time I was at Microsoft, we had to do, if we wanted to take a snapshot of a drive, that was a manual process, right? We didn't have automation that did that. I should, if I think there's if I identify there's a potential alert, I should automatically collect that forensic evidence, and an analyst shouldn't have to do it, right? Because that time I spent dorking around trying to snapshot a drive, right? There's other stuff I could be doing. And so an example would be like AI detects phishing, it blocks email, updates firewall rule, and notifies users, right? That's a very simple example. UEBA, user and entity behavior analytics. This is very important, right? If you think back to what we talked about with like one class SVM, right? AI establishes a normal behavior baselines. Anything that's not normal is an anomaly. This can detect insider threats or compromised accounts. I'm doing something different that I didn't do before, and I get flagged for it, right? Accessing files I've never accessed before at odds hours would trigger an investigation. I'm suddenly trying to log into a bunch of different machines, and I'm not getting in, but I'm still trying, right? Maybe I got an issue with the user account and I should deactivate it, right? These are the kinds of things that UEBA helps. Threat hunting, AI can help you proactively hunt threats by identifying subtle indicators that suggest that there's something that is not quite right. We've got something that is an anomaly. It's slightly outside of the realm of what we normally expect, and we flag it. And we've talked about network traffic. That's always a good one, right? Unusual traffic for analyst review, impossible travel, logging in from someplace I've never logged in before, an odd machine. I mean, we have a bunch of these protections in our stack already, but we would want to know about it. Reduces the time to respond, right? It shortens the time from detection to resolution. Used to be, I think the average was over 200 days, maybe close to 300. AI enhanced SOCs, the marketecture marketing says it's less than 24 hours. That's a huge improvement. And I can attest to that long tail, the number of days, right? Is, from experience, that's not necessarily wrong. It's like, oh gosh, they've been hanging around doing this for a long time. So, if you look at the diagram, AI ingests data from all the different security tools. And this is kind of an important point, right? Is you have data and you have to preserve it for evidentiary purposes, but you still want to do analysis on it. So how do you do that, right? Think about what we do with data pre-processing. if we take all of our data and we have a log sync and we preserve the unadulterated logs for evidentiary purposes, and we have a pipeline that only feeds us processed features for analysis, right? That's the value of an ML pipeline, is we have less data that goes into a security data lake, and it is, scaled and processed so that we're able to do machine learning on it. And then if we do find out something, we can go back to the original data and look at it in more depth, right? And then, we have agentic AI, right? These are the elements that make decisions, take actions. And then AI is going to coordinate the response across the entire stack. IBM said they reported a 95% reduction in time to investigate. And, I know for a fact Microsoft reduced alert volume by 90% and improved their detection accuracy significantly. So let's see what AI-powered SOC transformation looks like in practice. Okay, so again, this is from my example. And basically what I did is this, we've got 1,000 total events we're looking at. These are nice round numbers, right? It detects 100 anomalous events, and it tells you what type it is based on machine learning. It knows what a DDoS attack looks like. It knows how severe it is based on the asset, and what's the confidence that it happens, right? And these are all things that we're able to do in this example, right? And then we have this dashboard simulation, right? And it tells us the events, the high priority events, the ones that are auto-resolved, right? And what's that? That gives us like 70 events we have to investigate instead of 588. And it shows you these improvements, right? Shows the event volume over time, the incident distribution, MTTR, and of course it's going to look good because it's a demo, right? But these are the kinds of things that you can do with machine learning, right? All you'd have to do is put your own actual data in there. Probably wouldn't be quite this nifty, neat, and simple, but this gives you kind of an idea, right? In your KPIs, your total events, high priority, automated response, and then anomalies detected. All right. So these are the practical concrete benefits of AI and incident response. So what are the benefits of AI? We're going to have to get going here, guys. I'm sorry, we're really running out of time. So we can automate the incident remediation flow. We can classify the incidents faster. We can resolve issues on assets, right? Contextual data collection, right? We're going out and getting the information we need, and we're helping to marry that up to indicators of compromise. Reduce the time to detect anomalies, to figure out root cause, and make recommendations, and integrate different tools. So let's talk about these benefits in a little bit more detail. Okay, so speed and efficiency, right? We can reduce response times. Scalability, right? We're handling 1,000 incidents at a time instead of dripping them through and having to look at each one. I don't know about you, but I don't like sitting and looking at ServiceNow and trying to figure out what incidents I should deal with and what I shouldn't, right? I kind of have to investigate all of them, right? At that point. Accuracy, humans make errors. I know I've missed things. I think everybody that has been an incident handler has. Best practices, do you have a run book that is a doc that I have to open and go step through, or is it automated? And AI does it the same way every time. Proactively defend, right? We're leveraging intelligence. What should I pay attention to of these anomalous signals? Oh, this one looks like it's associated with the APT. I guess I want to look at that one. Resource optimization, we're freeing the analyst up from being in a swivel chair, and we're letting you handle strategic tasks, right? So speed means we have reduced downtime. Scalability means we have lower costs. Accuracy is fewer breaches. Consistency means that we're compliance and audit readiness. We do things the same all the time, and we can prove it. We're preventing things. We're shifting left versus being reactive. The cost is a lot less. and we're optimizing the resources. So Gartner estimates AI provides a 300 to 500% ROI within 18 months through reduced efforts of breach costs and operational efficiencies. And we all know breach costs can be unbounded. So let's see what these benefits look like if we quantify it with real data, right? So this again is from the simulation. So real with question marks, right? Or quotation marks, right? This is our response time distribution, right? We're able to get more done in less time. If you look at manual versus automated, we just can't handle as many incidents per hour. Mean time to resolve, right? Of course, in our example, the automated response is going to be a lot quicker. Sometimes there isn't an automated response, right? We do need to have a human analyst, but instead of spending this amount of time on all these particular things, we can focus on the high impact things like suspicious login, privilege escalation, network anomaly, that kind of stuff. And we don't have to worry about malware and phishing emails and DDoS and that kind of fun stuff, right? You look at the automation rate by severity, right? We want to highly automate critical incidents, right? And some of the lower impact stuff, maybe we don't care so much about. And we can really reduce our costs by automating our response. And again, this is all in the notebook, and it gives you the feature importance, and then it also gives you this response dashboard. All right, so what are our key takeaways here? What do we build? Automated incident response workflows, right? We generated some synthetic events. We implemented AI-powered triage, and again, all the AI stuff in here. This isn't just a bunch of graphs and stuff like this. This is all working stuff based on the data. Again, if it was real data, it would probably be more complex, right? It does the threat intel correlation for us, right? So it's looking at the activity and trying to correlate it back with threat intel, even though if it's synthetic. It's doing attack containment or remediation. We're doing containment based on incident type, and we've got systemic procedures, and we're transforming our SOC with AI. So we've seen how AI automates the workflows. We've talked about how AI-driven threat intelligence does correlation, helps us out. That's objective 2. We've observed attack containment and remediation in action, and witnessed a complete SOC transformation. So everything you see can be implemented using open source tools and cloud platforms. This is all done with scikit-learn and open source libraries. And I'm going to show you something else here again that is pretty profound. And what does this kind of relate to? Well, it comes out to this, right? My favorite, Streamlit. So I took that notebook and I asked Streamlit to make me a dashboard about what's in that notebook. And here it is, right? It shows me my events over time. It gives me my KPIs up here at the top. I have incident priority distribution here. The beauty of these graphs, right, is I can zoom in, I can zoom out, right? I can do all kinds of cool stuff. I could pop this out if I wanted to in full screen, right? I can go back. So this, again, open source, and I'm just a dumb guy, and I asked my LLM to build me a Streamlit dashboard, right? So you have all of this data available to you, even though this is just a demo. How long would it take you to get a data scientist and a developer to build this for you, right? It's going to take some time. This is all at your fingertips now as an AI wrangler for cybersecurity, because you can get this stuff done. And it's pretty profound, right? You've got playbooks, you've got response actions. And again, this is just a demo, so that there's more work to it. But this is the kind of stuff. I mean, what would your leaders say if you showed up to a meeting with a dashboard like this, right? They would say, "Hey, guess who's getting a raise?" Seriously. So, and this is all stuff that you can put in your portfolio. Okay. So we're almost out of time, so I'm going to keep blazing here. Sorry. So what are the challenges of AI and incident response, right? AI is powerful, but it's not magic, right? It needs a person to tell it what to do to train the model, right? This stuff just doesn't happen. You've seen this as part of us building solutions using LLMs, right? Sometimes there's some back and forth and it doesn't always make sense. You got to keep hacking at it, right? Your domain expertise and knowledge to be able to look at things and tell whether they make sense or not is key to being successful with any of these approaches, right? Being specific with your prompts, being specific with changes that you're trying to make as part of you developing your code, right? Um, and there's lots of limitations and potential issues, right? So we need to be honest about this. And AI is not a panacea. It is something that you need to control and you need to make work for you. And you can't just throw things out there without understanding it, right? You need to make sure that you are able to explain it, and you need to make sure that it's understandable to the end users, right? The interpretability, my favorite word that I can hardly pronounce. So let's talk about this real quick in detail, right, in our last 7 minutes. So what are the key things we need to be concerned about? Data quality and bias. The AI model's only as good as its training data. There's more to come here, but an interesting point got brought up about class imbalance in the malwares.csv. We talked about this a little bit. So we need to make sure that we understand what the data is and that it's good and that we're actually getting a result from a trained model that makes sense. The black box problem, right? Can you explain AI's decisions? If you can't, ask your LLM, describe this code. Tell me how this works in practice. What does this specific panel of this dashboard mean? How is it calculated, right? You will get that information. Look at the code too, right? You need to be able to understand what's going on in the code. It looks complicated. It might be unfamiliar, but if you look at it, it's chunked up, right? This is you can understand that much code. You might not be able to understand all this stuff at once, but you could understand what this little chunk is. So that's on you to be able to go through and understand what does each one of these things do. If you don't understand it, plug it into your LLM and ask, right? Adversarial AI, we talked about this. Attackers can find out in parts of your model where the margin is and what the precision and recall is around it. So they might be able to slip something in because they know kind of what that boundary condition is. So and so that's why your model needs to be robust and why there needs to be a human in the loop. Integration complexity. How do you connect this with existing security infrastructure? Hey, I built this thing in class. How do I put some real data into it? You're going to get the person that says you can't access that data because it's security data, right? So you might have to kick down some walls. Legacy SIMs might not integrate well with modern AI platforms. You might have to come up with a approach like a security data lake to centralize the stuff so you can run your models against it, right? And so you might have to do a phased implementation. Learn about APIs. How can you connect your model to an AI API so it can take action, right? Maybe we do something with a notebook and we do it stepwise. You can't reduce human oversight too much. You still need that human in the loop, right? It's not set and forget. You need to make sure that you have a way to make sure your model is working properly, right? If I say that it's 80% accurate and I have a high F1 score, how do I manage drift over time? How do I make sure that I always get those results as it runs? We need to make sure that we continue training and evaluating, and that requires people. What does it cost? It can be a significant investment. However, you can show these techniques off using open source tools, right? Show up with one of these notebooks and a Streamlit dashboard and say, hey, I got something to show you. People are going to be impressed. And you can find ways to scale these, right? And so you're going to move it out of Scikit. But I'll tell you what, the people who are doing analysis at all these major companies who are building the models that scale into commercial tools, they're using Scikit and all these open source libraries just the same as you. But when you get a model that works, how do you operationalize it? That's when you need your DevOps people, right? So best practices start with pilot programs in low risk areas. Make sure you have human oversight and that you're making the critical decisions and you understand and can explain things and it's interpretable. Uh, Invest in training. You all are here getting training. That's good. Now you need to take that training and that knowledge. How do you affect change doing that, right? Um, do things gradually. Do a pilot program. Do side by side, right? Here's the old process. Here's the new process. Let's see which one works better, right? We don't want to change anything too quickly, but we do want to show the potential advantages of it and also work out any bugs as we're going. So, it can take a year and a half to implement AI, and it's going to require significant organizational change. So you need to be ready to navigate that. But it all starts with having the data and being able to show a result and the way to measure whether you're actually getting it. So you have to understand both the benefits and the challenge. So let's do a quick summary here in the whole 1 minute I have left. Okay, so the key points are, right, we talked about these: data quality, we've got the black box problem, we have adversarial AI, it's complex to integrate, we can't be too reliant on it, we still got to keep people. So no, we're not going to get rid of tier 1 and tier 2, right? We still need people to be able to do things. We need humans in the loop. It's not going to be cheap. It's effective for me because you as an analyst, because you can show the potential, but to scale it and implement it in production, it can be hugely expensive, right? So you have to think about that. So, but you can get results, right? So again, pilot programs, human oversight, invest in training, plan for a gradual rollout, and kind of go from there. All right. So what should you do? Like look at SOAR platforms, Splunk, SOAR, IBM, free trials and demos, right? Learn more about what they're doing. Dheeraj, you have your question?
Yes, Professor. My question would be on the lines of when we are using AI for incident response, how can we ensure that there is no hallucination happening?
I think that that's a good question. When I think about hallucination, usually I think about an LLM returning incorrect information for a prompt, more than something more specific like a security problem. I'll have to think about that one though, but off the top of my head, I would say this, right? That if you're looking for something specific that you're taking an action on, the condition you're measuring should be quantifiable. So it's less like asking an open-ended question and more about your using the output of an ML algorithm to make a decision, right? So it's more concrete data, but it's a good question. I'll do some more digging on that because I think that deserves a more thoughtful response. But since we're over time, I don't want to. Okay, so let me get more information on it, Dheeraj. I think that's a good question though. All right. Okay, there's open source IR playbooks, right? SANS, NIST, there's a lot of GitHub contributions. Look at those. Certifications, I think the learning for a certification is useful. A certification in and of itself doesn't necessarily mean anything, but there's a lot of resume sorts that will sort on a certification. So you might consider that. Ask your LLM what are the top certifications that get sorted on for job submissions for cybersecurity, might give you some ideas. Hands-on learning, we're doing that now. All the code's up on GitHub, so download and run some of that stuff. Just ask your LLM to make you a Streamlight dashboard, right? Play with the examples and adapt the code. Use it for your capstone. I think that the analyst of the future is going to be an AI wrangler. It's not going to be somebody who just has security knowledge, right? You're going to have to do a lot more, and AI is going to help you do it. And I think that there's an emerging field of automation engineer using AI, and security is one of those places where you're going to have more opportunities. The capstone project and some of these dashboards, if you do those and you talk about them with your leadership, you're going to get people's attention, right? Nobody else is doing this stuff. So stay resilient. It's more in a catchphrase, right? There's resilience through AI and automation, but there's also resilience for you as a security practitioner. And you gotta move with the tide, right? Don't be the rock, be the river. This is the way things are going, and you can lead the pack instead of sitting around and wondering what's going to happen next, right? Make something happen and show people you know how to use ML and AI and the power of LLMs to get results. And I think that that's going to help us out a lot. Okay, that's all I got. Whew! Sorry. All right. Okay. So questions, please, in Discord. We're over time. Again, I apologize. So hopefully this was useful. The conversations I've been having with people, I feel like we're on the right track. If you feel like you're lost or you don't know what's going on, let me know. Hit me up with a DM. We'll see if we can figure it out. But we should all be at the point now where we have some confidence that we're able to be the AI wrangler for cybersecurity that people are looking for, and that we can be successful doing this moving forward. So that's all I got. All right. Thank you so much. And only 5 minutes over. So I guess I'm doing a little bit better. So thank you. And like I said, hit me up with any questions. And I'll see you next week. Have a great weekend. Bye.